Hello, this is Mr. Fraser, and I would like to welcome you to Lesson 2.2.
Mr. Camp, could you please come to the front office to see Mrs. Brock? Mr. Camp, please come to the front office to see Mrs.
2.2
Brock.
is linear functions. Okay, and we've talked about in 2.1 what function notation is. Function notation is when you use f of x, d of x, p of x, whatever it is, as long as whatever's in the parentheses describing the function is also used in the actual expression itself. So because we have an x here, we must also have an x here. If the expression was 3y plus 5, then this would be f of y. So understanding that the expression itself tells me what the function is in function notation. Okay. Two of the other concepts we're supposed to know is a graph continuous or discrete? And what is a continuous graph? Correct. A continuous graph is something that can have pieces. So for example, it's determined by our x value, and our x value tells us whether we can actually have pieces of it or not. So for example, if we were to use time, well, there are certain time problems where the actual time can be in pieces, so it would be continuous, meaning we could have 3.5 seconds or 3.5 seconds. But let's take one that would be discrete. A discrete time would be like if you rented a video and you had to turn it in by the day, and every day it was late,
Mr. Herning, please come to the
it cost you money.
Please come to booking.
It doesn't matter that it's a day and a half late, it only goes by full days. That information would then be discrete because your cost only changes every day. It's not cut into pieces. So it's understanding that when you have Girl Scout cookies, that Girl Scout cookies are bought by the box. That would be discrete because you can't buy half a box of Girl Scout cookies. I think they'd be a little upset. All right. The next thing we have to make sure that we're doing is that we are using complete sentences when answering our work. Okay. We're not always.
Please come to the front office and see Mrs. Brock. Mr. Camp, please come to the front office and see Mrs. Brock. Thank you.
I apologize for the interruptions. But we always are using complete sentences in the scenario that we're talking about so that we can understand what we are answering to. Okay, so two of the things that we have to be able to do for every word problem is you have to be able to identify what two things. Correct, you have to identify what the independent and the dependent quantities are. Okay? The independent and dependent quantities. Okay? And then you have to label your graph correctly. Independent, meaning it changes free without any other influence, and dependent, meaning whatever I put in for the independent tells me something about the dependent. So we have to understand that the independent most of the time is the quantity of time. And of course we have some other names for independent. So we're going to go ahead and make sure we know where the independent goes. It always goes on the x-axis. Okay. And independent is also known as our input. That means we're putting something in for the value of x. It's also known as our x value. There are some other names as well. Independent value. It's what we're plugging in. Okay. But we have to know what these words all mean. Okay. And then you have your dependent, which goes on the y, quantity. Okay. And this is known as the output, or y value, or f of x. These are all the same word for the answer. Okay. Output, answer, f of x, y value, they all have the same or similar meaning. And this is the y-axis. Now when we put the dependent and independent in, we also have to put the units that we're measuring them in. So if we had time, the unit would be either minutes or seconds or months or days, some sort of unit of time. And the same thing goes for your dependent quantity. It also is in a unit. Now, the weird thing, or the unusual thing you have to get used to, is that your units are always labeled in parentheses. Okay, so you have a dependent quantity, and then the unit is in parentheses. And those words are important because when you're reading questions, they tell you whether you're plugging it in for the x value and then doing the math, or if you're using the expression and this is the answer, and then you solve for x. Okay, so you're asking yourself, do I plug in for x, or do I put the expression equal to a number and solve for x. So you usually get a chart with this. Okay. So here's our table. Excuse me, not a chart, a table. And then you have your quantities up top. And then you have your units. And then you have your expression. Okay. Now the expression, one of them will always be a variable by itself. The other expression is the actual math problem. So in this case, we'll say it's 3x plus 2. Okay? And we will say that this unit is minutes. And this unit over here is we'll say dogs groomed. I'm just making this up. Okay, so that means if we had 5 dogs groomed, if we had 5 dogs groomed, we would put a 5 here, and the problem would be 3x plus 2 equals 5. And we would figure out how many minutes it took to have 5 dogs groomed. So you'd minus 2, and you get 3x equals 3. Dividing by 3, you'd get x equals 1. That means it took 1 minute to get 5 dogs groomed. Okay? That is your solution for x. Well, what if they told us you worked for 10 minutes? Well, now we put 10 in here. And this is an input. So that means we use the same expression, except we're now inputting 10 minutes. So the expression is 3x plus 2. Notice the expression never changes from when we're trying to solve for x or we're plugging in. It's all based on the words. They gave me 10 minutes, so I have to put in a 10 in the minute column. It's an input. So it would be 3 times 10 plus 2. You multiply 3 and 10 to get 30. Plus 2 is 32. Meaning you were able to groom 32 dogs in 10 minutes. Okay, so one of the keys is being able to write incomplete sentences. So let's look at this on a grander scale. If we say and put our information in the same columns all the time, that means our independent would go here, and our dependent goes here. That means if a number is the independent I will plug it in for x in the expression and solve. This becomes a calculator problem. I just do the math. Okay? So that means if it's here. But if it is in the dependent column,
Mr. Freeman, please,
then
call Ms. Brock or come up to the front office. Mr. Freeman, please call Ms.
this
Brock at extension
is
006
the
or come to the front office.
answer to the expression and we solve. Okay? That means we solve for x. Okay? So this one we plug it in and we do the math work on our calculator. This one we put it in as the answer and solve for whatever x may be. Okay? And we use the words or the units to tell us which column we put our information in. In this case, if we had dogs groomed, we put it here and it's the solution. And if it was minutes, we would put it here and plug it in. All right. So this was all the information that we were doing in 2.2. Okay, understanding how to fill out the graph, which graph, what goes on what parts of the graph, okay, as well as being able to label and function notation, understanding what function notation is, and Then being able to understand the difference between an increase and a decrease. And 2.2 mainly dealt with decreases. So knowing that anytime the number in front of x is positive, we have an increase. And again, this is a review from Unit 1. So when we had y equals 3x plus 2, this is an increasing line. It's linear because it has an x. And it's increasing because this number is positive. If the number in front of x was negative, we would know that it's still a line because it has x, but in this case now it's decreasing. This number is known as the rate of change. And this number is known as the y-intercept. It's also known as where I'm starting. This is my starting point. So using the dogs groomed thing, this means 2 dogs are groomed automatically. It means we start with having 2 dogs groomed no matter whether we had any minutes go by or not. So at 0 minutes we had 2 dogs done. Alright? But this is our starting point, or y-intercept. Okay. And that's where the line crosses the y-axis. Alright, so please make sure that you work on your skills practice. And then if you have any questions, please make sure you share them with me tomorrow. Alright, everyone have a nice night.